All right. Hey Lisa, how you doing, man? How's everything? Can you hear me?
Hey Paul, how are you?
Pretty good. Yeah, it's been busy, but how was your week?
It was good. How was your project at work?
It was fun. Usually there's like a lot of deadlines like coming in the last, few months. But
Yeah.
yeah, so like now, I mean, we're just waiting for a few things. How was your project with I remember you did the presentation, right?
Mm-hmm. It
Yeah.
was good.
Did you
Yeah,
guys? I heard from another colleague or like one of the other students that like she actually she was one of the, I don't know like apparently you guys have whoever has like the top three. I guess she said that she did one of the best ones.
oh
Uh,
yes, Sarah had one of the best ones I thought.
oh yeah, okay, that's good.
Yeah, she had one of the best ones I thought. Ours, our data proved, essentially proved our theory, our hypothesis was null
Okay.
and void, which
Oh, okay.
which made the girl who chose the topic was really angry about it. But it was like,
Oh, wow.
you're either going to prove it or you're not going to prove it, and that's the whole point of the data, was to tell the story, and it really just proved that it was not true. So
Okay.
I don't know, it was funny, but you know what, I'll try and find my presentation and send it to you, because I was the project lead on that.
Okay. I mean, like sometimes, yeah, that happens. I mean, you know that
it,
it's like research every time.
yeah,
You can't always force like the conclusion.
yeah, and that's what I tried like telling her, and she kind of seemed like upset about it, and so I was like, okay. So then when we wrote the conclusion, the guy who was presenting the conclusion was like, basically like, yeah, we didn't find any connections, we didn't find any relations to this, and
Yeah.
it just seemed very random. So,
Yeah. I mean,
and
yeah,
it's
like was that part of like the grading, or is it just as long as you guys presented your data in a systematic way, and then
yeah,
I explained that, yeah, maybe this was, when we proved that it wasn't the case, like it was, different from our hypothesis.
yeah,
Is that part of it? Just like that's not part, like, the result doesn't really tell you if it's positive, then that's a good grade. It's more like systematic, right? As long as you explain yourself.
yeah, it was more systematic.
Yeah.
I haven't gotten our grades, we haven't gotten our grades back yet. We should have gotten them last night, to be honest, but
Mm,
I
okay.
haven't seen anything. So we shall see.
What was your guys' topic again? I forget. That's why it's been a
Oh,
while.
mine was food. I kind of forgot what mine was about too. It was about food. Like, if you're a college student, are you if you live on campus, do you cook or do you go out to eat? Like, what was the relations between that?
Okay.
And it was just based on a um, data from Mercyhurst University, which was located in Pennsylvania, and said we wanted to see if the person's external environment influences their eating habits and perception of food.
Okay. I mean,
Yeah,
that's
it
good.
was
It's
interesting.
interesting. Did you guys have a lot of questions or like discussion points?
Some, if we had more time, we would have been able to pull more data and had more questions. But because we
Yeah.
were on short amount of time, it was we kind of went with just certain things, and that was it. And it was
Okay.
I felt our data was disproved.
Yeah. And then what were you guys like? What did you guys talk about for like conclusions? Or did you guys show like lib graphs or?
Yes, yeah.
Okay.
So two of the my team members did the matplotlib. I
Okay.
was actually supposed to do that, but then they were like, "Oh no, we'll just do it." I was like, "Oh, okay."
I guess fine. I mean, like it's not. I mean, you have to share like each part. You can't just do like. I mean, Matplotlib is pretty easy. As long as you, and that's usually the thing that you have. Like you have to show everyone the visual stuff. So as long as
Yeah,
you have like a plot, scatter plot, whatever, and then like a line bar graph, I think that's good to go. But like,
yeah.
how did you guys? I guess like since you said that it's the conclusion is different from your hypothesis. It's like how did the graph like in the end show? Like what was different about it?
Well, our conclusion, we just wrote that based on the conclusions, our data suggested there was no correlations that
Okay.
on the relationships we were looking at, and any correlation that we found was less than 0.01.
I see. Okay.
So
Yeah.
it was.
Did you guys do a heat map, a correlation matrix heat map?
No. So let me see. We did a bar chart. We did a scatter plot. We did quite a few scatter plots, to be honest.
Okay.
And then one pie chart, and then another bar chart. Yeah.
Okay.
And then this one girl, I don't because I don't understand statistics, but she was doing like the p-value or the
the hypothesis test.
yeah, and I
That's
was
not some type of t-test or
yeah,
whatever.
the t-test exactly, and I was like,
Yeah.
Okay, and she was trying to prove her theory. Like she was really like all
Adamant
about
about it.
yeah, we're like, it's okay. The data can show we were wrong. It's okay. Like
Yeah,
that's
it's
the
fine.
point of data. Like it's gonna tell the truth and it's gonna tell the story. So it's
No, it's fine. Like, yeah, usually that's the reason why. Yeah, sometimes I see where you're going now. Yeah, because like when the p-value is like less than like 0.05 or alpha,
mm-hmm.
you get like statistically significant. But if it's not, then you reject. Yeah, like it's a criteria, you know. Like,
Mm-hmm.
and you can just say like these things are the conclusion. I mean, in real life, like that's. I mean, it's a good thing that there's some statistically significant. But yeah, in the end, like you have a data, and then you're not trying to force the result
No.
because you're the data analyst. You're given data, and then you just need to have the conclusion, right?
Mm-hmm.
And it's up to the person who hired you to like take whatever you did, you
Yeah.
know, and then kind of like okay, that makes sense. So, but yeah,
Right?
that's good. That's good that you guys went through that process because that's really one of those things where like okay, you have a bunch of like futures that you're trying to test, and then like when your probability is set less than something, then they don't matter, or and then the other one is it does matter, and then in the end, so did you guys like create like a notebook of all?
Yes. Yeah,
Oh,
we
okay,
did. Yeah, we
yeah, that'll
did.
be good. Like yeah, if you want to send it to me, I would like to see this. Those are really good to have as like one of your projects for, like you guys are gonna do 3 projects, right?
Mm-hmm.
And then like that's kind of like milestones, like oh I did this one big one, and then the other ones later on.
Yeah.
But even
Which
yeah, and you can even say like it's always good to have like okay, you guys did it in a group, you presented it, the whole shebang, so you have that experience. Yeah.
yeah, which we did, and I think we did a good job presenting. We kept under the time limit. We presented well. I think we could have improved a little bit more personally, but
Okay. Yeah, it's fine. And then your group mates. That's the thing. You guys couldn't pick your group mates, right?
no, it was randomly chosen, which is fine too.
Yeah. Yeah. And then I think when are you guys doing your next one? Your next project?
I don't remember because they didn't give us a date on that, and we were all kind of like anticipating it. And we're all like, okay, what is it going to be on? Like, what is it? And they're like, well,
So you
we can't
can
tell.
plan ahead, right? So you can
Yeah,
plan
and they're
ahead.
like, we can't tell you. I'm like, okay.
Can't tell you. Yeah, I think that's what it is. Sometimes it's just you have to set boundaries and like that's kind of like press. Because like if you had all that time and there is no boundary, then you can be the most you can do the best thing ever. But in reality, you technically only have 2 weeks, right? You don't have like
Yeah.
2 months.
Yeah, you have 2 weeks, and then it's already hard enough because this boot camp's very fast paced, and it's like,
Oh yeah, and then they won't stop the homework
no,
while you're doing
no,
that. Yeah, I know. I
yeah,
know.
it's like super fast, and I'm like, I don't even know what I'm doing. Like, I'm still trying to like put 1+1 = 2 together. Like, so
Yeah.
it's just a lot, and it's kind of frustrating. But it's like, okay, well, I did my best. Here you go. I mean, I'm trying to understand it, but I only have so much time to understand. So it's
Yeah, but at
just
least you had like I guess someone that was good in statistics. I think that's always a good thing too, because like in
yeah,
data science, you could either just use the that's the thing, like you could either use a bunch of these different commands and then kind of just like filter your data and then show something about it. Oh, and then the other thing, the other level to it is like okay, let's do some statistics and actually interpret it.
mhm.
Like I don't know if you guys did you guys go over like the distributions in the class. I know you guys went over like these descriptive statistics like mean and standard deviation.
We did do those, yeah.
But like, did you guys remember? If you remember, do you guys cover like binomial distribution, geometric, all the normal distribution? Did you guys cover those?
I don't recall if we did. I don't
Okay.
think we did, yeah.
Yeah, because that's the other thing. Like you could also add that aspect to it, not just because there's in statistics there's like the standard deviation, right? And then like you have mean, variance, and these are just like point values, right? These are just like one value. And then like if you really want to get to like that advanced level, instead of like actually only knowing one value, you can do the whole thing, like a distribution. Like the t-test is a distribution, and then you from that distribution you can get like you can do whatever that your teammate did. You can figure out some p-value, and there's other ones that are called Anova. Like Anova is another test. Actually, maybe I'll cover that next time. Maybe just show it. It's actually very one thing that people really they ask questions about it. Like if you know how to perform like an Anova test or like a t-test, and then the normal distribution test, or z like if you take like the z value, I think that's cool. Okay. I forget where we left off. Do you remember what we talked about last time?
We started talking about NumPy or NumPy.
Did we finish it? Did we finish it though?
You know, I honestly don't remember, to be honest with you, because I know I canceled on you because I ended up going and helping my husband at his shop, and then you had.
I was so ready. I think I don't know. I forget what. That's why. That's why I kind of like let's go over the beginning where we touched on and I think that's good because then obviously like now I think now you guys are doing SQL, right?
Yeah, we were doing SQL. So that wasn't too bad, and we're doing it in Postgres.
Postgres, yeah. PG admin.
Yeah, apparently there's different types of SQLs from one of my classmates, because she's like, oh, I work in SQL all the time, and I don't work in this type of SQL. And I was like, what? But it wasn't too bad. Like it was okay.
Okay.
But we just went over this week. We went over this SQL alchemy, and oh my god.
Did you do the bonus on that homework? But from
no. No. I never do the bonuses.
I was able to. I think the time when I did it, like, it's weird because did any of your classmates do the bonus?
They probably did. I didn't because
okay.
I was just trying to get through the first part on my own, and
yeah. The first part isn't that bad. Like it's you just you could actually do that in either Postgres or MySQL, or you could even do it in like in Python. Like you can like type, because there's an SQL module in Python. Did you guys cover those?
Yeah, we did go over that during the SQL alchemy. We went over it on last Saturday, and they were showing us how like to start pulling it all together.
Yeah, it's good to do it in like after you do like the SQL. My other friend is doing this. I'm also like talking to her about it, where you can actually like like the whole pandas data frame thing. Like you have a data frame, and then you can pass that in an SQL in Python, and then from that you can filter it using SQL commands. So like it's really neat, like how Python can integrate like all these bunch of you could do it with Excel, and then like you could do it with SQL, and everything is just pretty much, and then you can do JSON as well, JSON files. It's just passing it through and then knowing the different commands, the different commands that you can do to that data set, and then anything that you do with the SQL commands you can do with pandas anyways, right? It's just a different way of doing it, like filtering.
Yeah, and I liked pandas, and SQL seemed fine, but like the SQL alchemy.
Yeah.
No. Especially last night's lesson. Oh my god, I was just we were going over like how to JSONify some things, and then we had to do APIs. I don't like APIs because I
don't like APIs either. But anyways, yeah, you do APIs.
Yeah, we have. So apparently on our new homework, we have to create our own API or something. And I was just like, oh my god, I gotta like figure all this. I don't know how I'm gonna do it, but
you have to create your own API and then do what with it? Like use some SQL commands or?
Yeah. So I'm like, I don't know what to do. So I'm just like, okay, I'm just gonna have to sit there and rewatch the recordings and try and like follow along and try
I'll probably end up doing that with you guys. I'm waiting for Sarah to send that to me. I'll look at it though. It's due next week Wednesday, right?
It's due next Wednesday. Yeah.
Yeah. So I'll probably look at it. If there's anything, I'll send it your way.
Okay.
Yeah, I usually do all of it, like all the beginning to the bonus, and see if there's anything there that you have questions on. Okay.
Okay.
Good
Well,
thing
yeah,
that,
and you also have my GitLab login too. So.
yeah.
Yeah.
So if it's already up, yeah, I'll look at it, and
Okay.
I'll send you my solution. And it's like, yeah. So maybe with that, like we could probably cover SQL like on Sunday, if anything.
Okay.
Are you free on Sunday?
You know what? It's actually my father-in-law's birthday Sunday, so let me see.
Oh,
Let me
okay.
let me get back to you, because if you could do a morning, that will probably work. Let me find out.
Okay.
Let me call my mother-in-law and see.
Okay. If not on we can always do Monday, like
Okay.
the usual Monday. Okay.
Yeah. Are you able to do Mondays like at 4 o'clock or what?
Yeah. Mondays are good. Right now I just wanted to do probably like Sundays and like Thursdays, like
Okay.
like the bulk of everything. But if you want Monday, yeah. But can you do Sundays usually? Like, can you usually do Sunday afternoons?
Yeah, I could do Sundays. Let me try and figure out which days will be better. What times will be better, because
Okay.
usually
Sundays in the afternoon for me is the best.
Sunday afternoon
After like 4.
after 4.
Yeah,
Okay.
because I have a 3 usually. Like 3 is always set every time. And so
Okay.
so 4 is like when I'm usually, I have other people. So yeah, that'll be good if you can do 4. Like 4 to whatever time.
Yeah. Okay. Yeah. Let me see. Let me talk to my mother-in-law and I'll get back to you. And then yeah, I'll see about doing a Sundays every
Okay.
Sunday if we can. Yeah, because that'll work out fine with me.
Yeah. Okay. Okay. So for
Okay.
today, I guess let's look over like NumPy.
Okay. How do you say it? It's NumPy.
It's NumPy. Yeah.
Okay.
It's Python, right? Like Pi
Yeah,
is
it's fine. Yeah.
I know it's not IE, but like this is Python. That's how you
Yeah.
spell it.
No, it's fine.
Yeah. Like Jupiter. But then the thing is Jupiter, right? Not Jupiter. So which is weird.
Yeah, it's Jupiter with the Y because of Python and.
But then it's Jupiter. It should be Jupiter, but no one pronounces it that way. But for the most part, I've heard it. The way it's pronounced is NumPy.
NumPy.
Yeah. Okay. So I think we did cover. Do you remember covering standard deviation and then like doing, because like these ones is just we'll talk about the commands or
Okay.
that you can use. So what I'm trying to do here is just create a list of like integers.
Mm-hmm.
And yeah, this does look different. I'm using VS Code. I'm not using Jupyter.
No, that's fine. I know what VS Code is.
So you've seen this before? Okay.
Oh yeah.
Okay, good. So you would import, and then what I'm trying to do here is just trying to compare what a standard deviation. If you were to, you remember we talked about defining a function.
Mm-hmm. It's DEF.
Yeah, and then I know we didn't cover a class, but sometimes what people will usually like ask you like is, do you know how to define like a function or define like a class as well? I know for you guys only probably talked about it, but you guys didn't cover what a class is, right?
No, I don't know what that is.
But a lot of times, yeah, people usually like require you to know what a class is.
Okay, so what is a class?
A class, we'll probably cover like a segment of that. But like
okay.
a class, just to preview it, is just another like a hierarchy of like function. Because like for the most part, you could create variables, right? And then you can just do the math, right? Like in any of these guys, in any code block. But then if you want to create like a setting where you want to like for loop, where you don't have to always type in the for loop or type in the math equations, you can create a function, right? And then it's just an input output thing. Whatever goes inside, you can output it by calling a function. But a class is just another level of that, where you can put a bunch of these functions inside like multiple lines inside the class. And the class just creates like multiple instances of a variable. There's a lot of theory to it, but what it is it's just creating a recipe that of like a program where every time you call a variable, which is called an instance of that class, it inherits every property of that class. So a class is just a recipe or a factory, and whatever the output is a bunch of these like an assembly line. There's a template, right? There's a template, So the class is the template, and whatever comes out is just a bunch of those instances. And the reason why you do that is so that every time you're creating a variable or they call it object, instance object, you're not reinventing the wheel or the recipe. Like what you're trying to do is if you want to create like human beings, like human 1, A, and B, and then they have different traits, you just change the class. Yeah.
Oh, okay.
Yeah, and then like they inherit all of the properties. The human being is gonna inherit all the properties by the recipe. We'll actually go over some of those. Like, it's great in creating like different database, because then you can just define the different properties of that database. And I know a lot of people they expect you to know that because this whole entire thing, even though no one talks about it, but it's actually everything is object oriented or object-oriented programming involves a class. But anyways, yeah. For this function, you remember we had the name of it, and then this is the input, right?
Mm-hmm.
So yeah, the input here is just this list that we have.
Okay.
So that's like I called it LST.
Yeah,
and then,
list. Okay.
Yeah, and then like if you because like this is just pretty much emulating what is inside this the standard deviation function inside the NumPy module. And what it is doing actually is just you're just taking the mean, right? And then you're dividing it. Let me see what's going on here. So, and then yeah, you're taking the mean and then getting a variance. And after that, where is it here? For each one of those, you're dividing it by the length. And because of standard deviation, just to like briefly talk about it, is just the square root of a variance, right?
Mm-hmm.
That's what's doing it. It's the square root of the variance, and then so that's what's inside this equation, this NumPy standard deviation equation. And then this is just me testing it. So you get like 2.82, and then if you did the NumPy like standard deviation right here. So np.array defines the list, right?
Mm-hmm. It's pulling off the list from the top.
Yeah. So like every time you do like if you have a list right here and you want to create like an array, you just feed it a list, and then it becomes a list. And then that list, if you want to create get the mean, you just do dot standard deviation or standard mean. Okay.
Okay.
So okay, the standard deviation, that's mean, and then we also have covariance. Did you guys talk about what a covariance is? So a bunch of these terms really are statistic terms. Just to like tell you, because yeah, they do like a lot of this, like you guys are gonna move on to machine learning, right? Like at the end. And machine learning has a bunch of theory of statistics. Like it's pretty much the whole thing is statistics.
Oh my gosh.
Yeah,
my gosh.
Yeah, it's fun though. It's fun. It's not that bad. Like machine learning, like all the different, because it's just a bunch of algorithms. And the two main things, the purpose of machine learning is to classify or to give you a regression. Classifying, like when you're classifying something, like for example, if you're trying to loan someone money, you need to classify them if they have good credit, bad credit, right?
Mm-hmm.
So that right there is a classification issue. You need machine learning for that. And then how do you know if someone has bad credit or good credit? You have to feed it to a system where it has a bunch of probability that tells you, okay, knowing all these different things, we're going to give it a probability. And then we're going to sum all this up and give you why they have good or bad credit.
Okay.
So that's like a statistics thing. All of that is statistics. And the other thing is like regression, where it gives you, okay, like after 10 years, what is that dollar? I guess that wouldn't work in that case. A regression would be like, maybe like in weather, like how like they have different temperatures.
Yeah.
So in weather mapping or wind, whatever, like temperatures and wind, that's also machine learning. They have all this like like maybe months and months, years and years of data, right? And then from that you have to predict like the next, like during that week, what are the different temperatures depending on the existing data. So you feed it to the system, you do some probability, and they give you this value, a unit. A unit can be like temperature, or it can be like wind. And that's regression. So that's it. That's in a nutshell. But then obviously your teacher is gonna talk about each one.
Yeah, I'm kind of scared now because this is a whole lot different than I thought it would be, but it's fine. I mean, it's fine.
Like in the beginning, it is just learning the different programs. It is what it is. Like in the beginning, you learn different programs, but then once you apply it, you have to they have to teach you. Like I don't know why. Like is your teacher telling or your professor is he telling you guys or does he have a section where he reviews statistics, like all the different like basics of statistics?
He did that. He did some statistics. I forgot when, but I was kind of like instant messaging with some classmates, and I was like, "What is he talking about?" And they're like, "Oh, statistics." I was like, "Oh my god!" I only did like a chapter of that in college, and I had a hard time. And
I know. Like a lot of times, like when people do statistics, it's just that it's this thing, the one with the standard deviation, right, and then the mean, all these different points, right? Like or like probability that, or like when you have like a bag of marbles, something like that. A bunch of that is just like that, but then it surprised me as well. Like when you do machine learning, like I didn't know what that was before, but then when I did it, it's like, oh, this whole thing is statistics. The whole thing is statistics. There's really nothing to explain it.
Oh my god.
Yeah, and like you think it's this really like people give it like these names, nomenclature, and then once you learn it, like, and then you kind of like think to yourself, like, yeah, like because every physical thing has like a mathematical like equivalent, right? Yeah, exactly.
And that's what the teacher. That's what Chris was saying. He's like, yeah, you don't have to be good at statistics. I mean, because if you just know how to input all the information, it'll pop it out for you. And I was like,
it'll pop it up for you, yeah.
Okay.
You learning the statistics aspect is if you like if you the only reason why you need to learn it like to that certain level is if you're trying to reinvent the wheel, the function, the function of all the different Python like machine learning functions. You can just use those, yeah, and then learn how to use their commands. But you don't need to like learn how to interpret. But you don't really need to know statistics if you don't need to reinvent those functions. Because like for example, like this guy, right? Like if you look at this guy, this is the math, right? But then if I didn't tell you this, you could just use standard deviation, right? Like from NumPy.
Yeah.
It'll give you the same value, right?
Yeah.
So it's the same with machine learning. You don't need to learn the math, the statistics. You just have to learn the command.
Just learn the command. Okay.
Yeah, and that's what it is. Like just learning the command is good enough. And then interpreting what does this value mean? What does 2.582 mean? That's good enough. You don't have to go. The only time you need to know a math is if you need to reinvent the standard deviation, or if it's like a function that has that no one defined yet in like the computer. That's the only time that you have to like know the math. Okay. Anyway, so like for covariance, so like usually when you want to find the covariance of something, so you're trying to find like it's kind of like the variance, like how it's a measure of variability between. So that's why like if two things, for example, like if something is like if height versus gender, is there any variability in that? Height versus gender. So X can be like height, maybe Y can be gender. And then so you have these two lists, and just to apply this covariance is really simple. You feed it two lists, right? Two columns.
Yeah.
And then whatever you pop out of this is so when you print the Z, you get this guy, right? And in this covariance, this is the thing, the correlation, right? Like it's kind of like the correlation matrix. You have this X, but in this case, you get 7.5 minus 7.5 minus 7.5 7.5, and then what you have here is really like X to X gives you 7.5, and then you have X and Y, the second column. It's like a negative value, and just know that what it pops up, it just gives you like the variability of like your list right here. So okay, as long as you know that it gives you have to feed it two lists, or two like columns, then just know that what it gives you. So I'll probably talk more about this if if we need to talk about like statistics, but like the physical meaning of it. But just right now, the only thing is like, okay, you can apply this to like two lists. And let's see, what's the other one here? What's another function? We talked about using shape in for pandas, right? I believe.
I think we did.
Yeah. So yeah, shape itself just tells you like the size of this guy. So 2 rows, 2 columns.
Mm-hmm.
Okay, and let's see. Oh yeah, this other one is the same thing as what we did before. The same way where you can index like a list, you could also index an array, right? In NumPy. So like for example, this AN array, which is the array that you created. If you did like 0, 1, and 2, it's just the same thing as getting all these different values, right? These guys.
Okay.
Do you remember how we index a list? Do you remember doing those?
Yeah, it's a square bracket. I remember that much.
Okay, and like when you're trying to access the element inside the list, which is these are the different elements of the list, right?
Uh-huh.
So yeah, the first one here is 3, which is 0 index.
Oh yeah, 0, 1. Yeah.
Yeah, exactly.
The columns start with 0 all the way down.
Yeah, and
so
then
0 is 1
and 2.
Yeah.
Yep. Yeah. So
Okay.
that's all I'm doing here. Just kind of reviewing NumPy.
Okay.
Yeah. And then if you wanna for NumPy, if you wanna, because it is a list, right?
Mm-hmm.
So a list, if you remember, there's a list, a dictionary, a tuple, and a set, right? Those are different collections. So the great thing about a list is you can change things inside the list, right? It's called mutable. So since it's mutable, this is something that you can do. You can take the element, this 30 or this 3 right here, the first element, and you can change it to something else, right?
Mm-hmm. Don't you have to do like an append, dot append?
You could do that if you're not using NumPy.
Oh, okay.
Yeah, but in this case, I guess it's kind of similar to what we did with when you do dot append. That's you're not replacing it. You could do dot replace, or you could just do this. You can do dot replace, like an array dot replace and parentheses, whatever's inside. What I'm trying to do here is whatever's inside this the first element, yeah, which is this guy, right? This is the first element.
Mm-hmm.
I want to change this 3 to whatever number, and then the resulting thing before it was 333 and 333. Now it's 888. You see what I mean, right? Like the first one got changed.
Yeah.
Yeah.
Okay.
So in NumPy, you can do the same thing. It's just really an extension of like the built-in list in Python. All right. So one of the great things about let me see if this is on. Okay. I mean, do you remember like you can create either a list, but then this is just 1D, right? Like it's only one dimensional. It's only like one list.
Oh yeah, yeah.
Yeah, and then and then when you do like a 2-dimensional, meaning like a table, right? Remember last time we talked about like you can have like a data frame is just pretty much a bunch of like rows and columns, which is a 2D array.
That's 2D, yeah.
Yeah, and then like when you're doing a series, that's like a 1D array. All right, a series is just 1 row, 1 column, and a data frame is a bunch of columns and rows. And in this case, this is a bunch of rows and columns, right? But it's just numbers. So you have 2 rows and 3 columns.
Yeah.
Well, and then what this does is the same thing as what I did here, right here, where because it's like double stepping. Like every time when you do like a NumPy array, you always apply it to like a list that's already created, which sometimes is a little confusing because you already created this guy, right? This is like a list within a list. But then when you're doing NumPy, you have to apply np.array.
Yeah.
Yeah. So yeah, just remember that. Like you guys already did that one. And then so okay, this is just a bunch of like what is the shape, and then let me see. Oh yeah, using the same way as where you can access like within like what a 1D array, you can access the first element. You can also access this kind of like the ilock. Do you remember the ilock?
Yeah, I didn't like iLock. Because
Yeah,
you have to know where the index is that you're calling out.
same thing. Yeah, same thing with this one. In this case, it makes sense because we're just talking about numbers. Yeah, I mean, either you know the index or you know the actual number within the array. So
Oh, okay, so on the np.array, you're gonna use the iLock a lot.
yeah, you're gonna use ilock every time. Yeah,
Okay.
I lock with one value like a 1D array, or I lock with two values. You can see it that way. I always see it that way. We're like, okay, it's the same as an I lock. But then what you're trying, I mean, though, like if you're trying to, if you look over here, this another is this thing right here, right? This is the another, right? Like this is just a variable.
Oh, another. Okay, I was like, what does another mean? Okay, it's a variable.
Yeah, that's why I'm highlighting it. So another variable right here is just this guy, right?
Okay.
Yeah, and then what I did here just to show is I'm applying this ilock pseudo thing where you have 0, 0, which is this 11 here, right?
Mm-hmm.
And then 0, 1 is this 12, isn't it?
Yes.
And then 1, 0 is what? What is 1, 0?
First, hold on.
Second row, first column.
Second row, first column. 21.
Yeah, so that's the guy right here.
0.
21.
Oh, okay. Yeah, 0, 1, 2. Okay.
Okay. And then, okay, so here's a bunch of other things that that NumPy gives you. You can create a bunch of zeros, like this. So you can actually do this. So if you wanted to create a bunch of zeros, instead of like inputting hard code the values like what we did previously, we hard coded the values, right?
Mm-hmm.
And what if you had like this 100 by 100 dimensional array, which is like impossible for you to hard code. So all you have to do is do this np.zeros, right?
Mm-hmm.
And then you just give it like the size. You give it the size. You want a 2 by 2 matrix or array that has everything, and every element is a 0. So that's all you have to do, np.zeros, and you give it the size. Yeah?
Okay, so now it's going to be 2 columns, 2 rows.
Yeah, 2 columns, 2 rows of zeros.
Okay, but and then the output is just zeros all around.
Yeah, and I'm just showing you how to use zeros. The reason why this command is useful is sometimes when later on, like when you try to apply it, I mean, in data science, yeah, you probably need to use it. Like where usually what you have to do is you initialize like an array, and like outside a loop, and then after you do the loop, you're gonna try to fill this array. But just know what it is now. Later on, if you ever have a question about it, we'll talk about it. But right now, just know how to define a bunch of zeros.
Okay.
So using NumPy, because it's usually the go-to when you're trying to do like these types of mathematical things. You usually use NumPy to define zeros. All right, and then this is the other one. Well, if you can define a bunch of zeros, why don't you define a bunch of like numbers, right? Like constant numbers. You can just do np.full.
Okay, what is np full?
So np full is just like another function that's kind of like zeros that gives you like a constant number for every element. And then all you have to feed it is kind of like zeros. This one, you could have done like comma 0, right? You could have done full comma 0. You could have done this the same way. Like you could have done like full 2 by 2 comma 0. It will give you this guy, right?
How? Okay.
Because whatever you put in the second thing here is just the value, right?
Oh, okay.
Yeah. So whatever you put on the second argument of np.full is just the value that you're gonna put for all the different elements within that, right? So I mean, you could I would just do 0, and then if you had another value besides 0, then you use full. But this makes sense, though, right? You've defined the size for first argument, and then the second argument is the value within the array. Yeah.
Yeah, I am in a weird way, I guess.
Because this 2 by 2 is the size of your array, right?
Okay.
And then this 9 right here is what you have for each one of these elements, right? Like each one of these guys is 9, right? It could be anybody. It doesn't have to be 9. It could be like 1. But it's a way for you to define.
Oh, okay. I see what you did. Oh, okay.
You know what I mean? Like I don't know.
Yeah.
I don't know how much clearer I can make that.
No, it just took it. Like I'm like, what is? Okay. Yeah, I get it.
I know. It's always good to go over these again. I know. I'm not trying. This is not something super complicated. It's just creating a bunch of constant numbers inside an array. This is what it's doing. Okay, but what about like, so you know how I create a bunch of ones here? So creating a bunch of ones, there's another function for that, and it's called these are two common ones, zeros and I. So I. Dot I gives you a bunch of it gives you like not a full one, like not everything is one, but it only gives you one in this guy in the diagonal. You know the diagonal right here, 1 and 1.
Yeah.
So
oh, okay.
that's all it gives you. It gives you the 2 by 2 where it gives 1 in the diagonal, like 1 and 1 here. Yeah.
Okay.
Yeah. And that's how you create that guy.
Okay. So an np.I, the numbers are going to be diagonally.
Yeah, there's I'm purposely not covering like why the heck do you need this? it's a linear algebra thing, which we're not gonna cover. You don't need it. Like I said, you just need to know like what they are, and in case you need to do something with it. Like someone asks you, oh, I need a bunch of like zeros for my matrix or this array. Then you know that you need to apply NumPy zeros. I need a bunch of like 1s or 2, whatever. I need a bunch. So a bunch of 1s. You do np.full. This one right here is if you want like, it's only 1. Like that's why it's called I. Because I is like 1. In essence, that's what it means. I would be like the letter I, but then it's actually I.
Yeah, like your eyeball.
Yeah, I don't know why I did that, but that's really what it means, like the letter I actually, because this one means I. Anyways, there's another one called ones. I guess this is the reason why they use I, because they're using ones for something else.
Okay.
So if you did ones, let me see if you can actually do 2 by 2. Okay, so you can actually do 2 by 2, right? So if you remember over here, we did the same thing. We did the same thing with the dot full. And then this one we did dot ones. So you could do the same exact thing here. But this one I think is like cleaner. It's easier to do. And then you just have to remember what dot ones mean. Dot ones mean you're gonna create a bunch of like elements with 1 only in all of them. And the only thing you have to define is the size of the element of the array, right? That's kind of similar to what we have here, right? The zeros one. So
okay, 0. Okay, and then dot. Okay.
Yeah, it's exactly the same. The only difference is you're putting a bunch of zeros here, and you're defining the size. Ones, you're putting a bunch of 1s here, and defining the size. Yeah.
Okay.
Yeah, that's it. I mean, those are like. Let me see if there's other ones. I mean, you already know what shape is, and you know how to do the this iLock thing. And then what else is in NumPy? Oh yeah, random numbers, right? You can do the random numbers. But you need this this NumPy itself. It has a function called .random.
Yes.
So and then .random is a function, but then within that, this actually is like I guess it's like a class. Like I said, a bunch of this is just a class. So NP is like the module, random is the class. The first random is the class. Then random right here with the 2 by 2 with the parentheses, this is actually the function. So there's random right here. How you define a random number is like this. And the only thing that you have to feed it, the input, is the size, yeah? It's just the size. Same exact thing. And the values for random is 0 to 1. You already know that one.
Yeah.
Yeah. And then, let's see. This one is the same. Slice indexing. Oh, actually, this one is kind of similar to what we did before. You know how like we did this, you could slice a data frame. Do you remember doing that?
Mm-hmm.
So kind of similar. For numbers, you just do like this colon and 2. So this first one is the rows, right? This first one. So this is the original one. This is the original one. So if you went with like all the rows, but then up to like the second one,
Up to the second row, yep.
or the third, or rather the third. Actually, no, 1, 2. But then yeah, the second one right here is the third one, but it doesn't include it, right? So it's only the first and second.
Mm-hmm.
And then for this one, 1, 2, 3, it'll be like 1 and 2, 3, but not including that. So it's just the middle two. So kind of similar as what you've been doing. And let's see. So for these other ones, we're just kind of repeating like what we've done. Let's see, integer at slice indexing. Which one is this one? Let's see. Row rank. Okay, no. Rank 1. Now let's not do this one. Array indexing for changing elements. For changing element, let's see, is a np.array 0, 1, 2, 1. No, we're not. Well, that's kind of similar. Okay, that's. Let me get matrix. I remember doing this one. So in the cell. Oh, okay, so answer did not modify. Oh yeah. Let's see if we can actually do some of these. In the cell below, modify the function. Get a portion of NumPy array. Okay. Actually run this one. I'm not gonna cover these ones because there's a bunch of things here where you're pretty much just this is how you confirm if the answer is this guy.
Okay.
But you have to use assert, which you don't really need to know that one.
Okay.
You just need to know like the NumPy stuff. Okay, so this one, Boolean.
True or false?
Yeah. Oh yeah, this one, filtering it. So if you remember, we did the remember the when you filter a data frame like this way, you can also do that with like that's why this is Boolean indexing is if you had like a data frame and then you only want something that's like greater than 15, right?
Mm-hmm.
And your data frame here or like your array is this guy, right?
Yeah.
And
So
then
it's going to list out the true or false. Let each item if it's going to be over 15. If it's over 15, it's true. If it's
yeah,
below 15, it's going to list as false. So
yeah.
instead of listing out the numbers, it's just going to be a Boolean.
And then if you want that one, all you have to do is do this, right? Like the filter right here is pretty much what you're feeding it.
Mm-hmm.
And so and this is how you do it with a data frame, where you had like the actual data frame or the array, and whatever you feed it inside the bracket is some type of Boolean indexing, and then the output of that is everything that's true, which is like this guy right here, right?
Yeah. Okay. Okay. So then that'll print out everything that is true when you do the print statement.
Yeah, but I think the one thing, let me think if because in the data frame it gives you the data frame. In this case, it'll give you a list. So you started with an array, right? A 3 by 2 array.
Mm-hmm.
And then now you apply this filter or whatever this greater than 15, you filter the array. It gives you a list though. No.
It turns into a list. It's just one row, so it's a list.
Yeah. So for the other one, you had a data frame and it gives you a column, right? Like for the data frame, it gives you a column.
Yeah, we had a column, but
yeah. In this case, it's kind of similar because you had a data frame, but then this one it only gives you a row. Yeah.
Okay. Yeah.
Because like you go from a 2D to a 1D, right? You go from a 2D.
Yeah. Okay.
Yeah, and then for like a data frame, it's kind of similar. The column or a row is, it's just the same. The column or row is the same thing, but it's just going in a different direction. But it always reduces it when you filter. It reduces at one dimension. Okay, so let me see this one. Oh yeah, this one is another one. So for example, let me see this one. You had an array, and you're doing this guy. Okay. So this one right here is when you're dividing it by 2, and the remainder. This is like another thing where you're dividing it. They're not when you're doing this modulo. Do you remember doing this? The modulo. The percentage sign. When you do percentage, whatever number is modulo 2. So like If you do modulo 2, that means it's the remainder is
Oh yeah, I remember we talked about that. I was
the
like, oh, we have remainders.
yeah. So the I'm just trying to explain like what this means. This means like when you do modulo 2 equals 0, this means you want the numbers inside the array, inside this array, right? This guy right here. This is the array right here. This guy, right?
Yeah.
You want the numbers that are even. So whatever, when you divide by 2, it doesn't give you a remainder. This is what this means.
Okay.
When you divide it by 2, you want the one that doesn't give you a remainder.
Gotcha.
So that means it's even, right?
Mm-hmm.
So and what we're trying to do here is, you want that value and you filtered it, right? On this left-hand side, you filtered it. And once you filtered it, you only have 12, 22, and 32, right? Does that make sense? Like this left-hand side right here is filtering the matrix right here, or the array.
Oh yeah, 12, 22. Okay, 32. Yeah, because those are all even.
Yeah. And then what I wanted to do is add 100 to it. Do you remember this plus equals? It means adding to it.
Yeah. Mm-hmm.
Yeah. So this is adding 100. So when you add 100, this is the result, right?
Oh, okay.
Because like it's 12, 22, 32, and those are the ones that fit this criteria right here.
Yeah, the 112.
Yeah.
Okay. Yeah. And then the 11, 21, and 31 just stay the same.
Yeah. The reason why is because it doesn't fit this criteria.
It doesn't fit. Yeah. Okay.
So yeah, I'm just showing you that you could do the same thing in a NumPy setting versus like when you're filtering like a data frame. But this, you already know how to do this. It's just knowing the different criteria that you can have and then what you can do with it. Okay, so let's see. This one, I don't think, let me see. This one does, we don't have to cover that one. Python assigns the data type. Okay, we've talked about the data types. That's the basic stuff. So let's converter. Which one is it? That modify line to convert each element of the material to NP. Return a new matrix with converted data type full of integers. Ooh, okay. So let's see. Let's not do that one. So this one, array operations. So you did np.ent, np array data type np.float, and then x plus y. Okay. So when you're doing arithmetic within an array, I don't know if you guys cover this, but I think you have to define like what they are. So this is just me defining the data type. So like, for example, you know what an array is. You know how to define an array, right? You just do np.array. Mm-hmm. And then you feed it like whatever array that you want. But then you want those values to be like either an integer or like a float.
What's a float again? Because that one is always fuzzy.
Okay, so a float is anything that has a decimal in it.
Oh, okay, that's right. Okay.
Yeah. So anything that has decimal in it, you're defining it. I think the reason why you're defining it here, because sometimes I think what the NP array doesn't really recognize that it's an integer or a float. So when you're doing the np.array, you're defining this d type means like you're defining each element. What does each element mean?
Okay.
So this is just me defining an x array and a y array. And then when you want to add them, you can add them this way, x plus y, obviously, right? And it'll add this to this guy, right? These two will be added.
Okay.
And then when you add these guys, you just add them by each element. So this guy right here will be added to this guy. Mm-hmm. This guy right here is going to be added to this guy. Wherever their position is, they're going to be added, right?
Yeah.
And then this guy right here is.
Well, what happened?
Here you go. And then, so you have this guy, and then so if you match them, they're pretty much this guy, right? Mm-hmm. Yeah.
Okay, I see what you did.
Okay.
I think I understand.
Okay. I don't want to explain the math part because
it's just adding that row 83 and 13.
It's just matrix addition. Yeah.
Yeah, that's easy. Okay.
Okay, and np.add. So does the NumPy function add? You could actually do it similarly to this guy, right? Like the same way as what you did here, you could
Yes.
do it here. Okay.
Okay.
All right. And then matrix subtraction, you could do this as well.
Okay, so
Similar
same
to
thing.
this guy. Yeah.
It's just we're subtracting.
Yeah.
Okay.
And then this next one is matrix multiplication. It's different though. So let me see if this is, when you're multiplying it here, let's see if the numbers match. So let's actually add something. So 3. Let's output what x is first. Print. Where's x? I thought we had it up here. Oh, because I didn't run it. That's why. Print x. Okay. And then the other one as well. So let's see.
Run it.
And let's
Print y.
Okay, so you have both of them just to check what they are, and let's actually do something with it. So let's see, 111 times 211.1. Okay, so it does do that. And then the other one, 12 times this guy. Okay, so it's not actually doing the, I don't know if we're actually going to cover that. Let me see if we're covering that one. Okay, so we're not, it's actually just doing the actual element multiplication. It's not doing the thing that I want it to do, which I don't think we need to cover that one. You remember dot, have you guys done dot product? I don't know if you guys did that one. Like, so it's just doing like specifically each element multiplied by each element, which is, in terms of like matrix multiplication, that doesn't really make sense. But I guess what it's doing is just it's multiplying each one of these guys. It's just doing these guys, but
Okay.
and that's how you're getting these elements, yeah. Yeah. Okay. So as long as you know that np.multiply does that, that's good. Subtract, add, and then divide. Divide is the same thing.
Same thing. Okay.
Whatever we went through, you do each element and you're dividing it by the same position of the other guy. So, 112 divided by this, 122 divided by this should give you the same thing here.
Okay.
So you could either do the built-in division for in Python, or you do the NumPy function divide. So both of them gives you the same thing, yeah. So as long as, yeah, I mean, there's multiple ways of doing it, but then if the NumPy way is NP and the actual word, multiply, subtraction, and divide. And let's see, this one, square root, yeah, that one. So for each one of these ones, you can do a square root of each element, similar.
Oh, okay, that's cool.
Same with the exponent, you do that. What about this one? Dot random, oh, okay. NP dot random dot rand, okay. So I guess this is another way of doing, from 2 to 5, yeah, instead of just doing like no argument. You can do a 2 by 4. All right, 1, 2, 3, yeah. So and you're timesing it by 10. So it's going to be from 1 to, which one? Set up a 2 by 4. Okay. So we've covered this, but the one thing that I want you to do is knowing how to, this is just the size. And then when you're timesing it, you're changing the number, the actual range of your random variable or random number.
Okay.
And I think, yeah, that mean we covered that one. This one, that mean access equals 1. Let's see that. We covered access before, right? Like access equals 1, like access equals 0. Do you remember what that means?
No.
Okay, let me, where's our ARR? Where's our ARR? Let me see. Okay, so it's this guy.
Yeah.
So ARR, this is our original matrix or array. And then when you do access equals 1, you're computing, you're adding everything in the
array.
In the mean, whatever this guy is, whatever you're applying the access to. So you have mean, right? And then you want to get the mean of the row. So this guy.
Okay, so the mean's going to be off of row 1.
Yeah, for across the row. When it says x equals 1, it's across the row. So this first
Okay.
one right here is the mean across this
row
row.
1. Okay.
And then
and then 4.4 is the mean of row 2.
Of this guy, yeah.
Okay.
Exactly. And then if you did 0, if you do like 0, that's going to be across the columns.
Okay, because 1 starts on rows, but 0 starts on columns.
Yeah. Oh yeah, I didn't define this. All right, so let's see. 1.
And
Yeah,
0.
so 0 is in the columns, yeah.
Oh, I see what it did. Okay.
Do you remember doing that? We did that in the data frame for pandas when we did the group by thing. It's just a bunch. So access is not just for pandas. It's pretty much like anytime that you're doing like some data frame or some matrix, which are all the same. And oh yeah, I guess this one shows you what that means. Okay, so let's see. This one, okay. What is this one? Create 10 element array of randoms, unsorted. Oh, okay, I see. And then this one, copy and sort. Oh, if you're gonna sort them. So yeah, you could apply like dot sort, kind of similar to what we did, right, with the pandas one. but in this case, I forget if we if you have to do like
the sorting, isn't it? Don't you need to identify the ascending or descending order?
Exactly, yeah. Like, let me see
Because
if you
it's
can
not
actually,
identified. Because right here it's not identified. That's why I'm.
let me see if you can actually do this for the sort in NumPy.
Okay.
Because in the data frame one with pandas, we did that one, right?
Yeah.
Yeah.
Because you would put .desc for descending, and yeah, I remember doing it. That's
okay. So in the sort one, the actual parameter or like argument is order. So if you did like order, you could actually do access as well. So order.
Are you typing something? Because I don't see it on the screen.
Oh, okay. So when you did this guy, right? You can do order equals, and let's see if you have to do sending. Okay. It's a little different. It's not the same as the other guy.
Okay.
Okay. Remember I did this with like dictionaries, but then the one with the dictionaries, it was just kind of similar to like a data frame, right?
Yeah.
You actually have, in that case, if you have like a key, then you sort it by that. Like the order is going to be, but that's the actual string that you have to order it by. But if you ordered it by like let me.
You can go on to something else.
Let me just see, because I remember doing this.
Okay.
Because by default, it looks like it's from you know, from negative to positive, and then it's ascending. But what if you want to do a descending? I guess the way that they're actually wanting you to do that is, if you remember doing something like this. You remember doing this?
Oh yes.
Let's see though, because okay, so that's that guy, but you want to print it, so let's actually put it right here.
Okay.
I don't know if you can do that.
It doesn't like the syntax.
np.sort. That's weird. There's order because or let me see. Oh, okay. Is it this? Let me see this one. So when you did -1, let's copy that guy in here. Gives you none. Okay, that's not. Okay, that one is negative. Okay, 1, 2, 1, 2.5. Oh, there you go.
So what did we do? Unsorted dot sort parenthesis print unsorted.
Yeah. So like
Square bracket.
from yeah. So this is what you have to do. It's a little weird, but like if you didn't do like this -1, you know, it's gonna be the other way, right? This guy. So
Oh, okay.
yeah. So descending is you add it, and then ascending is do that. Okay. So I know it's a little weird where sort should have like the actual sort function should have a way because like the other ones I know you can just define ascending or descending for for data frames, but this one doesn't. You could actually define the axis, but I don't, the same way as what we did up top here, but it doesn't tell you. Maybe you could look into it. I mean, maybe you could just search that sort if there's like another way, but that's one way.
Okay.
Okay, so let's see this one. We don't have to do this one. Let's see this one. Oh yeah, remember when you want to do like knowing what the actual elements are, you could do unique, right? Like for example, you have like multiple things inside your column or your data frame, whatever. You could do unique, and it tells you the different elements you have, the different types. Yeah. So you could
that was in pandas.
In pandas, you could do that for data frames, but here you could also do. I think it's let me say like dot unique. For the other one, I think it's like data frame dot unique. In NumPy, it's unique, and you have to feed it the array. Yeah. So yeah, this is the syntax. So you pretty much unique, and then whatever you feed it, it'll give you like a list. And let's see this one. So this one is S1 intersection. Oh yeah, I think this one's a good one too. Okay, so now you can actually create like not only a bunch of numbers for NumPy, you can do like strings.
A list?
Yeah. Oh. Of strings. Okay. And it will create, it's a little different, but it will create like this double list looking thing. So when you print it like this, but then, let's talk about what an intersection of like this list is. This is like one way of, I guess this is like intersection 1D. This is what it means because it's one dimensional. This thing is like it's like a series, right? It's just
okay. So that's is that considered one dimensional or two dimensional?
It's one dimensional because this S1 is just 1D, right? This
right here,
I'm just printing it.
Oh, okay. 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 The printing threw me off. Sorry.
Yeah. So the S1. So for example, like this S1. Okay, let's actually look at them separately so it's easier to see. ST. Okay, so this NP intersection 1D. When you're doing this, it will show you when you're comparing these two things where they have whatever's in common. So I don't know if did you guys cover? Do you remember in statistics or probability what an intersection or union is? Do you remember those two words, the intersection? I know it's a long ways back, but the intersection and union are statistical terms. I'm just bringing it in because sometimes people talk about it. And then like when you're an intersection, just to define what it is now, is when there's two things that's in common. And then a union is whatever it's kind of like the unique ones. Like it's not like all of them, but whatever is, in all of them, like, and it'll show you like one time. So for example, again, so intersection. If someone were to ask you, what's the elements that what's the intersection of list 1 and list 2? You have to look at this and see which ones they share. And the two elements that they share is bulb and chair, right?
Bulb and chair, yeah.
But union is...
But it includes bulb and chair.
Yeah, it includes bulb and chair, but then it doesn't have desk and lamp, right?
Like, but there's 2 bulb and chairs on the intersection, so it's still going to be included on union, but only included one time.
Because union is whatever is unique in all of them.
Okay.
Yeah, so it only shows up once.
Yeah, okay.
And intersection is whatever they share.
Whatever, okay.
Yeah. Maybe, yeah, so that's one way to explain what they are. But, you can always test this many times and then create your own and see what they're... But in essence, that's what it is. Let's see what this says. This one is elements in S1 that are not in S2. Oh, yeah, this one. So this function is set def 1D. So it'll tell you like what's in the first element, whatever you have in the first here, that's not in S2. So what is in S1 that's not in S2?
Desk.
Yeah. And if you switch it, obviously it's gonna be lamp, whatever. Then there's some significance to this, but you just have to know like what is this? One of the ways that you can apply it. And this next one, let's see, the intersection 1D is in 1D. Which element is in S1 is also in S2. So it's kind of like this, but then what is in S? It's like a Boolean though.
It's a Boolean, yeah.
It's a Boolean. So let's see. So it Booleans the S1 right here. Yeah, It's a Boolean of S1 because des isn't in the S2, right? It's only chair and bulb.
Yeah, and the same for S2. Lamp, it would be considered false, but bulb and chair are true because they're in S1 as well.
Yep. Yeah, that's good.
Okay.
So like just knowing these two are not as commonly used. These two right here, these last two. The first two, just know these are the most common ones: intersection and a union. So let's see, broadcasting. We talked about broadcasting before. Do you remember what broadcasting was?
No.
Okay. The word itself doesn't really, it's not automatic. Like, oh, broadcasting in weather or like network. But like what this means, really, I think it's like a bad nomenclature for what we're about to talk about. It's pretty much, you can define like a row and you can add it to all rows, or you define one column and you can add it to all columns. Yeah.
Okay.
So you have this guy. It's just a term, but then the way you do it is actually pretty easy. So this guy right here is like a bunch of zeros, right? And then I'm creating another row, 1, 0, 2. And then what I want to do is I'm going to add this one row to all the rows. So all you have to do is just add it. You don't have to create like a, 1, 0, 2, 1, 0, 2. You don't have to create a matrix like that. You can create one and you just add it by doing this. And that's broadcasting it, yeah? We covered this like last
yeah.
time.
Yeah, okay, no, I remember now.
Yep, and then this other one right here is great. Okay. So it's for the columns. So you create a column, and then once you do that, you add it to all these guys, right? The zeros. Or, yep, yeah. To add to the zero, so you get 0, 1, 2, 3, right? For all the columns.
Okay.
And this is just a column. This is how you define a column. It's the way you define like a row is only like a kind of like a series, only with one bracket. But with a column, you do this bracket thing, and you only add like one element inside, but it's double bracketed. That's just what it is, though.
Yeah, I get the double bracket part because it's
okay.
It's what
as long as you get that part.
Yeah, I don't know how to explain it, but I understand what it is because I mean we did it in SQL, we did it in Python, we've done it
many times. Okay, that's good.
Yeah, I've done it, and it's just
it's
I don't know.
Okay. As long as you know, once you see it, you know what it means. It's really just
But on SQL, it's different because if you're gonna like go on to the next line, you need to do like a ./ or something like that, and then you go on to the next line to right?
Yeah, like in
Okay.
SQL, there's just the way you create a table is different altogether, but then the
Hmm.
concept is the same. You know, you do
Yeah.
create table, blah blah blah, and then the filter. It's all the same concept: filtering, adding, columns, changing, but the syntax is different. But like, yeah, we'll cover that on the next one. I think it's a good thing. How comfortable are you with the SQL commands? If I know you guys only covered it once or twice, whatever. But the way, like, you know, pandas, in terms of like knowing how to do pandas, how to do NumPy, and I think SQL. I don't know if I mentioned to you, like SQL isn't as used much in data science versus like if you're doing like NumPy and pandas and the
Hmm.
matplotlib. Those are the main ones. If you have like SQL skills, that's good. But mainly you can do pandas commands, right? Like similarly to SQL, you can do the same thing in pandas. So
Okay. Yeah, SQL, I felt. I mean, I felt okay.
I just don't like the way, you know how like the way they create the tables. It seems like it's a longer way around it versus like creating it in pandas. Like
Yeah, it was.
pandas
I mean,
itself is the easiest way to work with a data set. Like,
okay.
like if you did like you know, creating a table, there's too many things that you have to type, and then you know and then you had like, what's that called, you had to put it, and there's a bunch of brackets, not bracket, but like putting it inside of parentheses.
Yeah, put in the parentheses, then you have to type like
The-
something varchar, and
yeah,
then
yeah,
label
it's
how
not
many
natural. I
varchars.
mean, I guess if you did it like so many times it becomes natural, but
Yeah, and then you have to hit comma, enter, do the thing again,
exactly,
do the thing,
exactly, yeah.
and then close the bracket or close the parenthesis, then do the semicolon, and then you can run
And
it.
and there's another parenthesis, and there's another parenthesis
Yeah.
after you create the table. It's like, why you, like in data frames, it's like one parenthesis, you're putting inside a variable, and then you're filtering it. But yeah, if you have to do it many times, just knowing the syntax, yeah, is good enough, but not really like mastering it. I'll see, like I
Yeah,
said,
and with the Jupyter notebook, or like with pandas, when you mess up on a syntax, it tells you on like the SQL, it just say line number 2.
oh yes, yes, yeah, yeah. If you're doing just SQL itself, yeah, it's different to interpret. If you're doing like the SQL version in Panda, or the Panda version of SQL, it still spits out the line, and I think that's actually a better way to learn it, is to know how to do it in Panda, in like Python, rather than like SQL. Because I think all the commands you can do in Panda, in Python, that you can also do in like pgadmin. You can do all of that in like Python. Okay, so let's see this one. And the time, create a list with values. Okay, let's not do that one. Oh, what is this one? So np the array. Okay. Let's actually move on. I want to move. Oh, okay. So this is a dot product one. I see what they did here. Determine the inner product of the. You haven't touched on what a vector, or maybe you did before.
No.
Okay, so let's not cover that. Because like the first thing that we covered was the multiplication of arrays, but a dot product, well, all these other stuff is just another like mathematical conundrum. So
Yeah. No, let's not do that.
okay, and let's see, random number generation. We've done that a lot. Merging data sets. Let's see, np.rand vstat. Okay, I mean that's another way that you could do this. So you know how like you can merge data frames?
Mm-hmm.
You could actually merge these different, like, in essence, it is a data frame, because you know, like, but it's just a bunch of numbers. So you have this k, right?
Mm-hmm.
And then this k is just this guy right here, and then you have m, which is this guy. And then if you want to merge them, you could do this NumPy command called vstat. So when you, and then vstat, just you just feed it like your different types of like matrices, and then when you do that, it will do this for you. So kind of similar, right? You're merging these two columns. So 3,
Okay.
48, 8, 18, but then, which is this guy, right?
Yes.
And then this other guy is 9, 11, which is like the bottom.
So it's just the bottom. Mm-hmm.
It stacks it pretty much. That's what it does.
Okay.
It stacks
Okay.
it. Yeah.
Stack equals stack.
Yeah.
Okay.
And then you could either use stack, vstack, or you can use concatenate.
Oh, concatenate. Yeah, that's our
Yeah.
favorite word in class.
Oh yeah, yeah. The word itself is really funny. It's only, I don't know if you ever use it in any other, like, you know.
Never. And in fact,
Never, right? Like, why would you ever use it in like colloquial language?
And it was funny because when he said that, I was like, "What is that connecting?" And then because I'm like, "Is that connecting?" Or and so I actually have I went on the dictionary and I was looking it up and I was like, "Oh, it does mean connecting." And I was
yeah,
like,
it does mean connect. Yeah, it does. Yeah, I did look that up before as well. But like, it's like one of those you know, like $5 or $10 word.
Yeah.
$5 word.
Oh,
like
no,
you never use.
It's your SAT words, is what it is.
Oh yeah. Before the old SAT, they had like a bunch of those words that you have to memorize. It is one of those, yeah.
I swear, I think that I've heard of them when I was in the SATs, but yeah.
Yeah. Okay. Anyways, so vstack is that, and then concat. As you can see, it's the same thing, right?
Mm-hmm.
But the syntax here is you have to use access. So access,
Okay.
let's see. Actually, I haven't actually tried using this for a while. So let's define this guy. Define this guy. And so what if we change this to 1? Okay, so that's what that means. So do you remember what access is? Like 1 is across and then 0 is in the column, right? I think that's what it means. So if you did like 1, it'll do it like, actually it's easier to interpret. Let me see. It's kind of like stack, but then it's the other way. It's like horizontal stacking, not vertical. Mm-hmm. Okay.
Okay.
And he could do H stack. So H stack is kind of similar to V stack. V stands for vertical, H is horizontal. Let's just see if that's, so this is, which one is it? 33, let me see. 27, the numbers are not, okay, that's why. 27, 48, yeah. So it's the same as this guy, but it's horizontal stack. The numbers were being weird. So it's pretty much just doing this and then tacking it to the right. That's what it's doing, pretty much horizontal. And when you do this, do you remember this dot T? Do you remember what this means?
No.
Okay. So dot T, the term for that is transpose. So transpose means just when you're doing the M right here, you know how like you had 28 and 31 and 28, 36? Mm-hmm. So all the columns become rows and rows become columns. So it's going to be, just to show you, so let's say m.t. So you see what happened? Like all the columns became rows and rows became columns, right?
Yeah.
So that's what it means. So transpose, I wanted to touch on because we're using it here. And then with concatenate and access. So yeah, just know what that is. And then, you know, I think the 3 different ways is like vstack, hstack, and concatenate. Those are 3 commands to merge your NumPy data set. And okay, we'll end with these ones, but you could actually remove your outliers. So let's see, X for 10, 36, let me see. And then this is your elements. Then you have your mean, cross your column. And the final list. Okay, so this one, see, this isn't this is just showing you like this guy, but with like the actual distribution. So this is the guy, and then whatever meets like the mean. Remember the distribution, like you had mean minus 2 standard deviation and plus 2 standard deviation. This is just what this means. Like it filters it where whichever meets the you know, like this mean is greater than, or the X that has a mean of minus 2 standard deviation, and whatever is in between, then like 2 standard deviation to like negative 2 standard deviation to positive 2 standard deviation. It filters this guy. So it removes like everything outside that. That's what it means by removing the outliers. So for example, what if you had like 3 or 2.1? Yeah.
Okay.
When I'm saying outliers, that means like, so this guy will only, the final list will only include values inside this array that are between the mean minus 2 standard deviation to mean plus 2 standard deviation.
Oh, okay.
Yeah,
Okay.
this is what it means. So that's why anything outside that is an outlier. Yeah.
Gotcha. Okay.
Yeah. So and then that's what this is doing. Okay. All right. So okay. So for Sunday, I think maybe we'll cover like the SQL commands in Python. I think that's like more relevant with what you guys are doing right now.
Okay.
So I think for NumPy, that's pretty much all the NumPy stuff that you need.
Yeah,
like,
that's fine.
And like Matplotlib, you already know how to do that, right?
Yes.
Yeah.
Well,
so
I mean,
yeah.
Not 100% confidence, but yeah, I kind of get it.
Yeah. No, because like Matplotlib is really, you know, very basic stuff, and then like.
Yeah, and I actually like Matplotlib.
Good.
When I did the homework, I was quite proud of myself because I did a lot of it, and then I couldn't figure out my scatter plot, and I even sent in a note, and I was like, "Hi, I couldn't figure out my scatter plot. Please let me know what I did wrong."
Yeah.
You know, because I think I just left out one piece of code or something. Like I don't know what I did wrong, but I couldn't figure it out. And then
know what you say.
And then they sent my homework assignment. When they sent it back after they graded it, I got a B+ on it.
It's fine.
Which is fine. I don't care. It's fine. But they're like, "Oh, your scatter plot is wrong," and I was like, "I know that. That's why I asked." Like,
well, he didn't. Well, that's kind of mean because like you asked them, right, and then they graded it.
Yeah, I'm actually not happy with our grading system because they tell us, you know, if you have questions because you didn't do something right, include it on your comments.
But then they grade it. Yeah.
And I do, and then they come back and they're like, "Oh, well, you're on the right track," and I'm like, "Okay, but that was not my question. My question is, where did I go wrong? And just tell me."
Yeah.
Or if, you know, if I did it completely wrong, you know, just mark it that I did it wrong and tell me why I did it wrong. So the grading isn't very, it's not valuable to me. So I'm just like, well, whatever.
Did you voice that out? Did you tell them that?
Well, I told my counselor that, and I told my instructor that, but they're like, "Oh, well, you know, it's just hit or miss, I guess." And I'm like, well, that's not doing me any good.
Take what you can get.
So, I mean, last night when I submitted my SQL homework, I just submitted it. I was like, I'm not going to even comment because what's the point?
Yeah. I mean, okay, so that's good. Maybe we'll cover it. Like, if you have questions, like those are the questions I meant. Like, tell me though. Actually, if you want, we'll look at the homework one that you guys did. And then like maybe we'll cover that first. The thing is, there's some things that actually I don't want to cover that because the bonus stuff in like Python is not working for our version of Python right now. So if there are questions, let me know though. Like you know, instead of asking your TA, because like your TA is obviously not helping you.
Yeah, well, I mean, they have 60 people in that class.
Yeah.
There's like 4 people, and I'm like.
Yeah, I know. It's a lot of stuff. But yeah, like for example, homework wise, this next one, maybe I'll just send you my solution and we'll talk about it before it's due.
Okay, yeah.
And then so that you can filter out all your questions.
Yeah, because that one I'm like already nervous. One of my classmates was like, "I'm stressing out," and I'm like, "Oh my gosh, if you're stressing out, then it's horrible."
Okay, I have another appointment, but yeah, let me know on Sunday or if Monday works, either one.
Oh, okay, will do. Thank you, Paul.
All right, Lisa, thank you.
Have a good one. Bye.
You too.